class, see you again. Today we will discuss factorizations. So without further ado, let us start our lesson for today. So the first method in factorizations is extract the common factors. Okay, so what is the common factors? Common factors is when you are given two numbers, they have the same factors. So if let's say you need more details on what is common factors, you can refer back to my Form 1 video about the common factors. Okay, let us look at the first questions. A, 7x plus 14. Alright, so how do we find common factor for these two terms? Right, okay, so 7x and 14, we find the common factor which is 7. So 7x divided by 7, we get x. 14 divided by 7, we get 2. So we are done factorizing by extracting the common factor out. So for the 7 here, we'll write over this side. And the x plus 2 will be in the bracket. Alright? So we try another examples here. We have 60GH and then 28GF. Alright? We use the divisions method. Right? First, we start with the number. So the number 16 and 28, there has the common factor of 4. 16 divided by 4, we get 4. And then we copy down the GH. 28 divided by 4, we get 7. And then we have 7GF. Okay, we are not done yet because we have 4GH and 7GF here. So now the next common factor is G. So we have 4H after we divide this with G, and this we're left with 7F. Okay, so we are done extracting the common factor. Now we write our answer here. So 4 times G. So for this one, okay, for this part here, you need to multiply. So we get 4G. And this one we'll put in the bracket. So we have 4H plus 7F. Okay, so that's it about the extract common factors. Now, we look at the second method, which is factorizations using the perfect square. Now, how do we factorize using this method? Okay, first thing, normally for this kind of questions, we will have two terms. Okay, then the second thing is that for these two terms, we will be able to square root it perfectly. Okay, before we discuss further how do we find this, let me show you something first. Okay, we have A plus B, A minus B. So we do expansions for this. A times A, we get A squared. A times negative B, we get negative AB. B times A, we get positive AB. B times B, we get negative B squared. So now let us simplify this. We left with A squared minus B squared. Alright, so now let us compare this to our perfect square type of questions. You will see they are quite similar. So when we want to factorize this type of questions, we will have this as our answer, A plus B, A minus B form. Okay, because in expansions is from this form to this. This is expansions. Okay, and when we do factorizations, we are reversing. So our final answer normally for this kind of questions, you will have 1 plus and 1 minus in the bracket. Okay, now let us look at these. Okay, let us put in the two brackets like this first. We have 1 plus and 1 minus. Okay, we square root of 9x squared. So square root of 9x squared, we get 3x. And over this side, we also get 3x. And square root of y squared, we get y and y. Another one here. Okay, as simple as that. Okay, right. So next questions. You will look at this quite similar to perfect square. But the problem is that you see, if let's say we have something like this, you cannot perfect square root it, isn't it? Okay, so the first thing we need to do is to extract the common factor for this kind of equation. So x squared negative 50. So the common factor for this is 2. So we extract the 2 out, we're left with 4x squared, and this part we're left with negative 25. So we extract the common factor out if, let's say, the two terms is not the terms that you can perfect square it. Okay, so minus 25. So now then we find the factors. So very easy. We put two brackets. One is plus, one is minus. So we square root 4x. Here will be 2x. Okay, and then square root of 25. We have 5 and 5. Very easy, very simple, and very straightforward. Okay. So next, the third method is grouping the term with the common factors. So for this kind of questions, okay, you will notice that we have 4 terms, 1, 2, 3, 4. So before we can group this, we can solve this kind of questions, right? We will need to identify the one with common factor. We pay it in a pair. So we look at this 3a squared x plus 6a squared y minus 2bx minus 4by. Both of them, you can see they will have same common factors like this one. Okay, 3a squared and plus 6a squared. They have the common factors. So this one will make a pair, and then negative 2bx and negative 4by, this will make another pair. So once you identify the pair, then we can next extract the common factor. So the common factor for this pair, 3a squared x plus 6a squared y, is 3a squared. Then after you extract it out, we have x left, and for this we'll have 2y. Okay, if let's say like this, you cannot see, you can always 6a squared divided by 3a squared. So a squared cancel off, 3, 1, and 2. We have 2y. Alright? And next for this one, we have negative 2b as our common factor. So once we extract out, you are left with x only. And for this negative 4b, since this is a negative, here also negative, then this will be a positive. So you take out 4b, you take out 2b from 4b, we are left with 2y. Alright, so class, when we have this kind of questions, we must come to these steps where you can see the first thing in the bracket and the second bracket, they are the same. So now what we need to do is just this one outside the bracket, we group it in another bracket, in one bracket, and for the x plus 2y, we put it in bracket, and we are done with the factorizations. Very simple. Okay, next. Right. So what if, let's say, we have something like this? Okay, you see 3mn plus 3n squared. Okay, they can make a pair because they have 3 and n. Alright, we look at the second part, negative m, negative n. Oh no, they don't have the same factors. How? Alright, so if let's say we get questions like this, the first thing we rearrange them. Okay, so sometimes you don't get them arranged accordingly. So what you need to do, you need to arrange them so that they can make in a pair. Okay, with the common factors of plus 3n squared minus n. So once we pair them, this one will be one pair. This one will be another pair. So we look at the first one. Okay, the m and m is the common factor. So we extract the m out. So we're left with 3n, and then this will be minus 1. Okay, then we look at the second pair. So 3n squared minus n. So the common factor is n. Okay, so 3n squared you take out n. Okay, we left with 3n, and this one we're left with 1. So do you see that? We got two brackets is the same. Alright, so class here. If let's say when you do extracting or factorization, somehow you don't get these two the same. So you must check back because it is a sign that you don't do the factorizations correctly. Alright, so Then we group that n plus n in one bracket and then 3n minus 1 in another bracket. So that is the third method. So next we will look at the factorizations using cross method. Okay, now so I will say that cross method you can apply for any type of the equations. All right, it will not restrict to any type of equations, right? So it can be either 3 terms or 2 terms, but most of the time it will be 3 terms. So when we want to factorize using this method, okay, look at this. Okay, we have x squared. Okay, the factors for x squared will be x only. And whereas the factor for 22, okay, will have maybe 1 times 22 or maybe 2 times 11. Okay, now the decisions of the factor for 22, it will be depends on the terms in the middle. So now let us draw something like this. Okay, we let our negative 9x over here. So since this one is only one factor, we can put our x over here. Now, we want to get to 9x. So let us try the first combinations. If let's say 22 minus 1, do we get to 9? No, we don't. Or 22 plus 1? No, we don't, because we get 23. But if let's say we choose 2 and 11, where 11 minus 2, yes, you get to 9. So our choice of factor will be 2 and 11. Okay, let us cross multiply first. So x times 2, we get 2x. And x times 11, we get 11x. Now, you look at here, we have negative 9x. From these combinations, we need to get negative 9x. So we need to say 11x must be negative, 2x must be positive, because positive 2x plus negative 11x, we get to negative 9x. So now, just now we cross multiply here, right? So this part, okay, the 11 will come with negative sign and the 2 will come with positive sign, right? Okay. Now, before we write our answer over here, we do the last steps of checking. Okay, we multiply down x times x squared. 2 times 11, we get negative 22. Okay, these steps will help us to check whether we have factorized correctly or not. So x squared, yes, correct. We compare with the equations. X squared, yes, correct. Negative 22, correct. And then negative 9x is also correct. So this means that we have factorized correctly. So now we write our factors here. X plus 2, x minus 11. So we are done with the factorizations using cross method. Let us try another questions here. Okay, we have 2x squared minus 5x plus 3. So the factors for this, okay, will have x and 2x. Okay, and for 3, only 1 and 3, no other factors. If let's say this is the case, it will be easier for us. Alright, now the negative 5x we write over here. Okay, we have x and 2x. Now, how are we going to arrange our 1 and 3? So if let's say we put like 3, 1, okay, you get 3x, and then you get 2x here. Alright? Okay, so now we want to get to negative 5x, meaning to say these two must be negative, negative, then we get to negative 5x, right? So when we cross multiply this, we have to give negative and this one as well. Alright, so x times 2x, let us do the checking. X times 2x, we get 2x squared. Negative 1 times negative 3, we get positive 3. So compare that with your equations. Yes, everything is the same. Then we have done the factorizations correctly. So our answer for this, x minus 1 and 2x minus 3. Alright, so now we have gone through all the factorizations method. I hope the video can help you. So if let's say any of you need further assistance on the homework or in your lesson, do feel free to email me. Okay, to email me and let me know how can I help you. Okay, if you need a personal tutor or homework help, please email me. Thank you, and I see you in the next video.